Okay. So we'll pick up from where we left last time. We are talking about some application layer protocols, and the first protocol that we are going to talk about is the most common one that we use every day. HTTP, web and HTTP. We'll talk about web and HTTP. We established that HTTP is an application layer protocol which requires data transfer without any loss. So what happens if the packets they get lost? So it will require the underneath transport layer protocol to provide this reliable service. So that means HTTP will be running over TCP. HTTP at the application layer will be running over TCP at the transport layer. Last time we discussed that different application layer protocols have different reliability requirements. So HTTP is one of those protocols in which you want to transfer the bits. You are requesting a file and you want that file exactly as it is on the server side, exactly bit by bit. So that means you will require reliability. And since you require reliability, that means your underneath protocol, the protocol over which the HTTP application layer protocol is running, it has to provide that reliability. So that means we can't use UDP here. We will have to use TCP. Okay. So web and HTTP, as we are familiar with, you send a request for an object, basically for an HTML file, or probably a PHP script or something like that. So some file will be generated or already present at the server side, and the file will be sent back to you. So you send a request for index.html file on a server in the file structure, and the server will send that file to you. You can also send a request for an image file, and the server will send the image file to you, or a video file, and the video file will come to you. Okay. So web pages, they consist of objects. There is one base HTML file, and within that HTML file, you can have embedded objects, each of which can be stored on different web servers or maybe on the same web server. हो सकता है एक ही web server पे हो within the file system, or these objects can be on different web servers. So objects can be base HTML file, JPEG image, Java applets, audio file, etc. So web page will consist of this base HTML file, which includes several embedded objects or referenced objects. Within the base HTML file, there will be a tag, reference tag, which will say that within this file, at some particular point within the file, you have to display an image or 2 images or 5 images. Okay. So you will have to specify the name of the host, and within the host name, there will be some directory structure or file system. जिसके अंदर ये file सेव हुई होगी, pic.jf जो है वहाँ पे सेव हुई है. You send a request for this file. Your HTML request should include this path. you will make a connection to www.someschool.edu, whatever is the IP address of that. Okay. Once the connection is established, you will send an HTTP request. You will send an HTTP request for this specific file, which is somewhere in the file system. Somewhere in the file system, and the server will oblige by sending back that file to you, and your browser will do whatever it wants to do with that. Yes.
जब initially HTML फाइल बेस में आ रहे थे तो एक TCP कनेक्शन एस्टैब्लिश हुआ वो कनेक्शन उसी कनेक्शन से हम कोई इमेजेस भी मंगवाते हैं या
so we'll come to that. You can use the same TCP connection, or you can close that TCP connection and establish a new TCP connection for. So that will give you two flavors of HTTP. Two flavors of HTTP. Persistent flavor and non-persistent flavor. We'll talk about that in a minute. Okay. So HTTP is web application layer protocol. This is the application layer protocol used for the web for requesting web objects and receiving those web objects for consumption, display in the browser or do whatever you want. Uses the client server model. The client is your browser, which could be running on your phone or your computer, laptop, etc. And it is implementing the HTTP protocol. The browser will be sending the request to the server, and the server will be sending back the file to the browser. Very simple request response message. Very simple message. Obviously, there are details. The message itself will contain that HTTP request, and the response will contain the HTTP response. Uski koi format hogi, which is specified in the RFC. So the web server will send back the object in response to the request, and the request can be sent from a PC, for example. Will send a request, and the response will be sent back by the server. So this server can also get the request from this iPhone, which is running another browser. Will send the request and will get the response. Any client can send the request to this server, and the server will send the response back to the client. So HTTP, as we said, uses TCP because HTTP requires reliability. So the client will initiate the TCP connection first. So the first step that we will do when you are using HTTP, so you type a URL in your browser behind the scenes. First, it will resolve the IP address by using DNS system into resolve the domain name into the equivalent IP address. Once the IP address is known, will make a TCP connection behind the scenes, a TCP connection to that server. And then after the TCP connection is established, now you have this connection over which you can send the HTTP request and get the HTTP responses. Okay. So the server will accept the TCP connection from the client. HTTP messages exchanged between the browser and the web server over that TCP connection. And after the exchange is done, request and response, after those are finished, you will close the TCP connection. You may close the TCP connection, or you can leave it open for subsequent requests as well. HTTP is a stateless protocol. What that means is that the server side does not have a notion of knowing that this is a repeat client which is coming to me. Okay. So the server maintains no information about the past interaction with the client. But we do know that in reality, you have to maintain the state somehow. Okay. So everyone uses Gmail or webmail, Outlook 365 पे use करते हैं या Gmail पे use करते हैं. So you don't want the server to forget you every time. You send a request, HTTP request, email load हो जाती है. उसके बाद दोबारा से you don't need to log in again and things like that. So somehow the server remembers you. But that is not part of HTTP. You have to do some fixes. You have to do some band-aids such that the server remembers you. Okay. We will talk about that. So the protocols that maintain the state are complex. The server has to maintain this information. The client has to maintain this information. What happens if the network connection breaks? when the two sides are not synchronized, you will have to make sure that these need to be synchronized. So HTTP runs over TCP. It uses the services of the TCP. The TCP is the underlying protocol. So whenever the client wants to establish, so to send an HTTP request to the server, before it can send the HTTP request, a TCP connection needs to be established. And in order to establish the TCP connection, we will talk about the details of establishing the TCP connection in the next chapter. But in essence, it consists of three exchanges of packets. So first is the TCP SYN packet. A TCP SYN packet will be sent from the client to the server. The server will acknowledge that. The server will acknowledge that TCP SYN plus ACK. SYN is a synchronizing packet, and then you will acknowledge that packet, and finally you will have a TCP ACK. This is called the three-way TCP handshake. After this is completed, we say that the TCP connection is established. Once again, the details of this connection will come back in the next chapter when we'll talk about TCP. Abhi zara application layer pe focus kar. But we do know that the application will require the secretary to work underneath. So this is the secretarial establishment. So after the TCP connection is established, within this with this packet that you have sent, in which TCP acknowledgement has been sent, included in this packet, or maybe a separate packet, you can send an HTTP GET request. And what is an HTTP GET request? HTTP has different types of requests. HTTP GET request is one type of HTTP request. One type of HTTP request. So you'll send the HTTP GET request, and then you will get the response. Maybe it will send subsequent requests and will get the responses. So these purple lines here, they are indicating the HTTP application layer interaction. Application layer interaction. The green lines here, are the transport layer interaction. We must first have the secretaries ready to communicate with each other before the CEOs can exchange messages with each other. Okay. So these application layer view is limited to these purple lines. Application layer does not know how these secretaries are setting up things. Okay. Maybe this secretary is talking to the secretary that I'm sending you a packet starting with sequence number 5. Remember, we said that we have to have sequence numbers. Sequence numbers किस लिए चाहिए थे पैकेट्स के अंदर? Ordering के लिए चाहिए. Ordering के लिए चाहिए थे, so that if some packets are lost, you can resend those. So application layer view is limited to these purple lines. Now, to answer your question, the HTTP connections, there are two flavors of HTTP connections. That really depends upon that after sending the HTTP request and getting the HTTP response, what do you do with the TCP connection underneath? नीचे वाला जो TCP connection है, उसके साथ क्या करते हैं? If you close that, that means if you want to get another object from that server, you will have to re-establish another new TCP connection. Without the existence of TCP connection, you cannot send the HTTP request and response. Okay. So in the case of non-persistent HTTP, you will establish the TCP connection, send an HTTP request, get the HTTP response, and close the TCP connection. That's the non-persistent HTTP. So TCP connection opened, at most one object sent over the TCP connection. This is the HTTP request response interaction. Okay. And after that, the TCP connection is closed. Okay. If you want to download multiple objects, if you want to request for an image file which was embedded or referenced within the base HTML file that you had first requested, उस object file के लिए, उस image file के लिए, you will have to establish a new TCP connection, send a request for the image file, and will get the image file, and then close the TCP connection again. So that means for each object, you will have to establish a TCP connection. You'll have to establish a TCP connection. Now, how much time does it take? How much time does it take? Well, we saw that in order to establish a TCP connection, you have to spend one round trip time. ये एक आपके पास एक round trip time लगेगा. उसके बाद you will be able to send the HTTP request और उसका response फिर आएगा एक और round trip time लगेगा. And then the object can be very, very large. It can take a long time, long transmission time for the object. यहाँ तो दिखाई नहीं है object. Okay. So in the case of persistent HTTP, you will have these TCP connections remain open. You will leave the TCP connection open, okay? And multiple objects can be sent over the single TCP connection between the client and the server, So in one way, this is bringing efficiency to the HTTP. Remember, we have to waste this time, one round trip time for establishment of the TCP connection and another round trip time to send the HTTP request and get the response. दो round trip times के बाद अब हमारे पास डेटा आना शुरू होता है. दो round trip times के बाद हमारे पास डेटा आना शुरू होता है. यहाँ पे for the first object, there is no way out. You have to establish that TCP connection, send the HTTP request, get the response. After two round trip times, you will start getting the data. After the first object is completely received, now you don't need to establish the TCP connection for the case of persistent HTTP. You don't need to establish that TCP connection because it's already there. You have not closed it. You can use the same TCP connection, save one round trip time, and send the request for the next guy. Save the request for the next guy, send the next HTTP request, and get the response. One round trip time फिर भी लगेगा. आपने request भेजी, उसके बाद उसका जवाब आया, and then you will get the data. So non-persistent TCP example. You have client on the left side and server on the right side. So let's say you are requesting a file, some home.index file, which contains text and references to 10 different images, 10 JPEG images. एक base file है, उस base file के अंदर 10 images हैं. These are all separate objects. हर एक का अपना URL. You are only requesting the base HTML file with one URL. That base HTML file will include the references to all the URLs to all the other objects. Yes. So persistence means that this client and this server, उनके दरमियान हमने जो TCP connection establish कर दी. If you want to establish a TCP connection with somebody else, that's a new TCP connection, of course. So if you want to get the image, if the reference image is hosted at a third party, then you will need to establish a new TCP connection for that third party anyway.
So can a machine maintain multiple simultaneous TCP persistent connections?
Can a machine maintain multiple simultaneous TCP persistent connection means parallel TCP connection? That the answer is yes. Yes. Multiple TCP connections आप open कर सकते हैं. In fact, अगर download accelerators किसी ने use किया, how many people use download accelerators? Yes, few people. Really? बाकियों ने नहीं use की. बहुत टाइम बचता है उससे. कभी वो HD movies कभी नहीं download की वो 16 GB वाली. हाँ? 16 GB वाली भी डाउनलोड करें, सिंगल TCP कनेक्शन पे डाउनलोड करें और 2 दिन के बाद आएगी. प्लम्स के कनेक्शन पे हो तो 4 दिन के बाद आएगी. So डाउनलोड एक्सेलरेटर्स यही काम करते हैं. तो पैरेलल TCP कनेक्शंस खोल रहे थे and then they request parts of the object, वो जो फाइल है वहाँ पे बड़ी फाइल है, parts of that big file are received on different TCP connections. The server must support those multiple TCP connections को, parallel TCP connections को support करना चाहिए. Yes.
So what is the cost of maintaining a TCP connection?
The cost of maintaining a TCP connection is, the operating system on your side or the server side has to deal with that. That's the only cost. there is another cost which we don't know yet. And that other cost is, remember we said TCP uses congestion control and flow control. Anyone remembers कि flow control क्यों करता था TCP? Why did TCP do flow control? Flow control क्यों किया?
So as to not overwhelm the network.
So as not to overwhelm the
Network.
no, so as not to overwhelm the receiver. So as not to overwhelm the receiver. ठीक है? Receiver को overwhelming से बचाने के लिए बेचारा वहाँ पे low CPU वाला आपने receiver लगा दिया. You don't want this server to send data at enormous speed to that guy. The guy will not be able to process it. So to avoid that, you will need to pace up or pace off. Okay. If you want to avoid congestion of the network, to avoid the network from overwhelming, you use congestion control. So, bazaar aisa lagta hai, it seems that congestion control, flow control will have similar kind of mechanisms. Why? Because in both cases, you are trying to save some entity from being overwhelmed. लेकिन एक केस में वो entity network है, दूसरे केस में वो entity एक single, there is one single guy, the receiver on the other side. Okay. And the methods used for flow control and congestion control are completely different. Flow control is pretty easy. Okay. It is done by using the packets themselves. उनके बीच में कुछ लिख देते हैं. Receiver कहता है कि ओ इससे ज़्यादा speed पे data नहीं भेजना, मैं नहीं बर्दाश्त कर सकता. Within the packet, it will write that this is the maximum speed at which I can receive the data. Pretty much इसी तरह लिखते हैं. Because whenever you have a connection, the packets are exchanged on both sides. दोनों साइडों पे आ रहे हैं, तो दूसरी साइड से जो पैकेट इधर आ रहे हैं, उसमें उसने maximum speed लिख दी है. मैंने अब this is my responsibility to not send the data faster than that speed. Similarly, the packets that I am sending, I will write the maximum speed at which I am willing to send the data. My processor can sustain that data. तो दूसरे की फिर अपनी जिम्मेदारी है कि वो नहीं भेजेगा. So flow control is this. इससे ज़्यादा और कुछ नहीं है flow control. Congestion control is very difficult. It's very intricate. Why? Because you have this shared network which is being shared by thousands of users or hundreds of thousands of users or even millions of users, depending upon where the endpoints of the connection. There is one endpoint here and one endpoint across the world. The packets are going through these service provider networks at the tier 1. You have lots and lots of traffic going through that tier 1 network. कुछ पता नहीं कहाँ से traffic आ रही. So you want to make sure that you are not overwhelming the network. The way that TCP works is that TCP tries to snatch every bandwidth that it is available to it. लेकिन उसको पता नहीं है और लोगों ने कितना नेटवर्क यूज किया होगा, तो हमें पता नहीं है बैंडविड्थ कितनी अवेलेबल होती है. So the principle behind TCP, we'll talk about this in more detail in the next chapter. But the basic principle behind congestion control of TCP is that increase the data rate on getting the good news, and then we'll see what good news is, okay? And decrease the data rate on getting the bad news. Okay? What could be good news and bad news? Good news क्या हो सकती है? कोई acknowledgement आ गई कि पैकेट रिसीव हो, कोई acknowledgement आ गई कि पैकेट रिसीव हो गया, that's a good news. तो सेंडर क्या और तेजी से भेज, वो डबल कर देगा अपने रेट को, एक्चुअली डबल भी कर देगा किसी भी केस, और इंक्रीज कर देगा लीनियरली और एक्सपोनेंशियली, पर इंक्रीज करेगा. इट्स अ गुड न्यूज दैट पैकेट हैज रीच्ड द रिसीवर, रिसीवर हैज सेंट मी द एक्नॉलेजमेंट. इट्स अ गुड न्यूज दैट मींस देयर इज स्पेस इन द नेटवर्क व्हिच कैन टेक माय पैकेट्स टू द रिसीवर. यहाँ पे रिसीवर की लिमिटेशन नहीं है, नेटवर्क की लिमिटेशन है. एंड व्हाट इज अ बैड न्यूज? What is a bad news? पैकेट ड्रॉप हो गई. पैकेट ड्रॉप का मुझे पता नहीं चलता. नो एक्नॉलेजमेंट, टाइम आउट हो गया. We talked about timeouts. टाइम आउट हो गया, that's a bad news. टाइम आउट हो गया, bad news. In fact, एक्नॉलेजमेंट आपको नहीं मिली, in some way that can be considered as a bad news. Okay? We don't know कि acknowledgement नहीं मिली तो वो उसको कैसे पता चलेगा कि अभी थोड़ी देर में आ नहीं जाएगी. So we don't know this detail, and we won't know this detail until the next chapter when we talk about the reliable protocol. But at the high level, we do understand what is a good news, what is a bad news. Good news is packets are getting delivered. Bad news are packets are getting dropped. The packets are getting dropped because the queues on the switches in between, they are getting filled up. They are getting filled up by other network traffic. बाकी सारे लोग इतनी ट्रैफिक भेज रहे हैं, नेटवर्क में इतनी गुंजाइश नहीं है. Network is getting overwhelmed. So जब भी bad news मिलेगी, you will back off. You will need to back off. You will decrease the rate. So I won't say more about congestion control and flow control right now. अभी तो हमारा अच्छा टॉपिक ही. But we do understand that congestion control ऐसे come. So पता नहीं इसका दिक्कत क्या है. So you send the request for this base file, and then this base file contains these additional images, referenced images. So that means आपको वो सब भी मंगवाने पड़ेंगे ब्राउजर में डिस्प्ले करने. So first the HTTP client initiates the TCP connection to HTTP server at this address, जिसका equivalent कोई भी IP address होगा, on port 80. And we said last time that by default HTTP operates on port 80. You can configure a web server to be run on any port, but अगर कहीं आपने configure नहीं किया तो by default वो port 80 पे run होगा. Download an HTTP server software, आपको open source मिल जाएगा, उसको run करेंगे port 80 पे run. So HTTP server at host, waiting for the TCP connection. It's waiting, it's listening. Remember listening की command की उसमें. At port 80 will accept the connection. Once it accepts the connection, it will notify the client. The client will get notified, and the client then knows that a TCP connection has been established. TCP का वो 3-way handshake complete करेगा. उसके फौरन बाद HTTP client sends the HTTP request message. We don't know how it looks like. We will know in a few minutes. Okay? So it will send the HTTP request message for this particular object, into that TCP connection socket. Message indicates the client wants this object. And the HTTP server receives the request message, and it will send the response message back. So again, we don't know the format of the request message and the response message, but we do know that they will be following some protocol because the language has to be common. The server and client, they need to understand each other. ठीक है, वहाँ ऐसा नहीं हो सकता वहाँ पे फ्रेंच लिखी और यहाँ जर्मन लिखी. So it has to be request and response messages should be according to some standard. वो हमने RFC के अंदर लिख दी. So HTTP server receives the request message, forms the response message containing the requested object, and send the message into its socket. वो वहाँ से वापस चला जाएगा. Now, after that, the HTTP server will close the connection because it was non-persistent HTTP. Non-persistent HTTP, पहली object उसको मिली, connection closed हो गया. So HTTP client receives the response message containing the HTML file, displays the HTML, parsing that HTML file, it finds that there are 10 referenced objects. कोई उसके अंदर 10 images पड़े हैं. अब उसको वो सारे भी मंगवाने हैं. लेकिन ये TCP connection close हो गया, तो वो steps 1 to 5 repeat करेगा for each of those 10 images. TCP connection पहले establish करेगा, फिर उसके बाद request भेजेगा, और उसके बाद response जो आएगा, एक object आएगी उनको display करता है. This happens very fast. So non-persistent HTTP का response time क्या होता है? So you initiate the TCP connection. It will take one round trip time for sending the SYN packet and getting the SYN ACK back. SYN ACK packet back आएगा. उसके बाद you can send the HTTP request. You will request the file by sending this HTTP request. By the way, इसी के साथ ही आप SYN ACK इसके साथ ही मिला के भेज देंगे. अलग भी भेज सकते हैं, but normally SYN ACK packet जो होता है वो इसके साथ ही भेज देते हैं. In fact, the same packet उसके अंदर आप HTML request में भेज देते हैं, HTTP request में भेज देते हैं. So after that, the server will start sending the file to you. और फिर जितना भी time लगेगा उसको. The width of this blue strip here, it really depends upon what is the size of the file. What is the size of the file? Big file will take long time to be transmitted. Transmission time उसका ज़्यादा होगा. And the file completes reception at the client end. The file will be received at the end of this blue strip. So HTTP response time per object is 1 RTT to initiate this TCP connection and 1 RTT for sending the HTTP request and start getting the response and then the transmission time of the entire file. And we know that the transmission time does depend upon at what speed the link is operating on. क्या उसकी bandwidth है 10 megabit per second, 5 megabit per second, and also depends upon how much data do you want to receive or send. So file अगर बड़ी होगी तो ज़्यादा time लगेगा उसको transmit होने में, transmission time उसका ज़्यादा. So non-persistent HTTP का response time would be 2 RTT plus the file transmission time, approximately. So what are the issues here? It requires 2 RTTs per object. There are 2 RTTs, one for the establishment of the TCP connection, one for sending the HTTP request on that TCP connection and start getting the response. And the browsers often open multiple parallel TCP connections to fetch referenced objects in parallel. In parallel, browser जो है वो ये काम कर सकते हैं. Oh, by the way, ये parallel TCP connection पे जो question था वो congestion control का होता है. So basically the TCP congestion control algorithm, we don't know how it works. We will know, but it allocates bandwidth fairly to everyone. What does that mean? That means that if there are many people using the same network, it will try to allocate bandwidth in proportion. 10 लोग हैं तो 1/10 सबको दे देगा. 10 अगर TCP connections जा रही हैं, so 1/10 of the bandwidth of the link, of the border length link, will be allocated to each of those TCP connections. अगर 50 connections हैं, तो 1/50 सबको मिल जाएगी. Now you think about parallel TCP connections. I am one guy. And I have opened 1000 TCP connections. It looks like to the network, it looks like there are 1000 different guys who are trying to use that network. Okay? So वो क्या करेगा? So 1000 मेरे connections हैं. Let's say there are 1000 other guys as well. Okay? 1000 different guys. So total 2000 हो गए. So 1/2000 सबको मिल जाएगी. But उसमें से 1000 तो मेरे ही हैं. So that means half of the network bandwidth वो तो मैं hog करूँ. Okay. So by doing this, you are basically creating unfairness by creating parallel TCP connections. ये जो download accelerators करते हैं. So very interesting. If everyone is using a single TCP connection to download a file through a bottleneck link, सबको बराबर bandwidth मिलेगी. If one guy uses a download accelerator, opens multiple TCP connections, will get more bandwidth. But if everyone does that, it's the same thing as everyone using a single TCP connection. The thing is that not everyone does that. So इसलिए किसी का फायदा हो जाता है, बाकियों की cost. So coming back to non-persistent HTTP. So non-persistent HTTP में ये time ज़्यादा होते हैं. So we have this persistent HTTP. By the way, non-persistent HTTP was the default for HTTP 1.0. 1997 से पहले जो HTTP use होता था, 4-5 साल use हुआ है. HTTP started in early to mid 90s, 92, 93. तो कुछ साल के लिए वो HTTP 1.0, फिर उसके बाद it continued its use, but 97 में उन्होंने standardize कर दिया था HTTP 1.1 को, which includes persistent HTTP, which is the persistent HTTP standard. the server will leave the connection open after sending the response. So the TCP connection, एक दफा open किया, you can use that TCP connection for sending multiple HTTP requests, getting the responses to those HTTP requests. So subsequent HTTP messages between the same client server sent over the open connection. The benefit is that you are saving that one round trip time. So जहाँ 2 round trip times आपके waste होते थे, वहाँ पे अब 1 round trip time waste होगा. You still have to send the request for HTTP request आपने भेजनी है, HTTP response आपने. So 2 के बजाय 1. But you know, this is 50% reduction. This is 50% reduction in response time. So not bad. So client will send the request as soon as it encounters a reference object, as little as 1 RTT for all the reference objects, cutting the response time in roughly half. So what are the performance advantages of persistent HTTP? Persistent HTTP के क्या advantages हैं? So once again, you initiate the TCP connection, send ACK and then ACK, and उसके साथ ही आप HTTP request भेजेंगे. You are sending this HTTP request here, and then you are getting the response. File is received here. As soon as the file is received, or whenever you are ready, you can use the same TCP connection to send the request for the next file. So request for the next file can be sent right away. And the next file will come back to you. Okay? It would spend 1 extra. इसका जो overhead है, वो 1 RTT. 1 RTT is the extra overhead. So this will avoid the connection setup overhead for subsequent file requests. उसके लिए ये avoid करेगा. So this also allows TCP to learn more accurate RTT estimates. Now, once again, this is a topic that we will see in chapter 3 when we talk about TCP in detail. But TCP की वर्किंग के लिए TCP को राउंड ट्रिप टाइम के एस्टिमेट्स पता होने चाहिए. वो कैसे एस्टिमेट करता है? मूविंग एवरेज कैलकुलेट करता है. एक पैकेट भेजा, कोई पैकेट उसका रिस्पांस वापस आया या एक्नॉलेजमेंट उसकी वापस आई है, कितना टाइम लगा. So you will get an estimate of round trip time, and then you can calculate the moving average of all of these round trip time. So TCP uses this round trip time. To perform many of its functions. Okay? Details uski next chapter mein. TCP also uses this. The congestion window ek uski hoti hai. Once again, we don't know anything about congestion window, but हमें आपको कहा था कि TCP congestion का जो algorithm है, वो ऐसा कि good news आएगी तो rate increase कर देंगे, bad news आएगी तो rate decrease कर देंगे. Very simple strategy. This is what you should do. Okay, if you want to avoid overwhelming the network, any protocol would do that. कि अगर नेटवर्क में गुंजाइश है तो और भेज दो, अगर नहीं है तो थोड़ा कम कर लेते हैं. So TCP congestion window will increase. Congestion window tells you about how fast you can send the data. If the congestion window is large, then you can send the data large amount of data in a short period of time. Okay? So ये अगर एक छोटा सा कनेक्शन होगा, शॉर्ट लिव्ड कनेक्शन होगा TCP, so you opened a TCP connection, उसके ऊपर HTTP रिक्वेस्ट भेजी, आगे बाद एक फाइल आ गई, so some amount of data, उस दौरान आपने अपनी कंजेशन विंडो को इंक्रीज किया, but the network was empty. Now you opened a new TCP connection, वो फिर स्क्रैच से स्टार्ट करेगा. उसको अब उसके गुड न्यूज है, वो उसको नहीं पता पहले वाले TCP कनेक्शन में क्या हुआ था. उसको तो बहुत गुड न्यूज मिल रही थी, लेकिन उस बेचारे के पास डेटा ही खत्म हो गया. अब वो क्या करे? You opened a new TCP connection, you started from scratch. Now you are still getting good news. You will keep on increasing the data rate. Congestion window बढ़ाते जा रहे हैं. ठीक है? You keep on increasing the data rate, but for how long? बस जितना डेटा है भेजना है उतना ही देर तक इंक्रीज कर सकते हैं, उससे ज्यादा नहीं इंक्रीज कर सकते. डेटा खत्म हो गया तो फिर TCP कनेक्शन खत्म हो जाएगा. But if you have a single TCP connection, as in the case of persistent HTTP, that means कि all the files सारी उसी TCP connection के ऊपर जा रही हैं. So that means that TCP connection can make use of the good news which are received during one file transfer for the subsequent files as well. उनके दौरान भी वो अपना congestion window बढ़ा देगा, rate बढ़ा देगा. उन जो good news उसे मिली थी तो वो rate बढ़ाता जाएगा. So that means कि subsequent files may reach faster. Question?
So regarding congestion control, हमारे जो modern browsers हैं, ये वाली strategy को नहीं follow करते हैं. I would say
Browsers will आप हमें जो नजर आएगा वो HTTP, हमें सिर्फ एप्लीकेशन नजर आएगी. Remember जब हमने लेयर्स की बात की थी, हमने कहा था एक फिजिकल लेयर हमें नजर आती है, एक एप्लीकेशन लेयर नजर आती है. You don't see anything in between, but everything exists. The TCP exists there. TCP की congestion window हमें नजर नहीं आ रही है, but that doesn't mean it's not working. It is working. It is working. It is increasing on good news. It is decreasing on bad news.
so वो big pipe connection, अगर हम deep load करें कोई indexes में,
हाँ.
we see that the initial they are pipe connections. So there was a fixed fee.
ख्याल आपका ख्याल ठीक नहीं है. फिक्स नहीं रहते हैं. हमें नजर नहीं आता. That doesn't mean कि वो फिक्स रहते हैं. ठीक है. और कोई प्रश्न? Yes.
Browsing a website and wanted to use persistent HTTP. Action of it is there के लिए हम पे establish करेगा as long as the page is loaded या फिर जब तक मैंने I am on the website.
Configurable है. थोड़े से के बाद जो है वो खत्म भी हो सकता है. टाइम आउट हो जाए उसमें या एक्सपायर हो जाए. That is a configurable. Yeah. Okay. So persistent HTTP. So it's bringing efficiency to HTTP. It's bringing efficiency to HTTP. कैसे? कि पहली फाइल के लिए तो देखें RTT दो RTT ओवरहेड हैं और उसके बाद आपके पास फाइल आ जाती है. For all the subsequent files, you have just one overhead, one RTT overhead. So कुछ और काम करते हैं, उस one RTT को भी बचाते हैं. लेकिन it's not possible. अभी लग नहीं रहा कि उसको बचाया जा सकता, because you have to send the request and you have to get the response. ये तो नहीं हो सकता कि वो पहले से ही भेज दे. हमारी रिक्वेस्ट के बगैर ही तो सर्वर नहीं भेज सकता. So ये तो होगा ही होगा. But what if I have to get 10 objects? 10 objects हैं, तो ये पहली object 10 embedded objects हैं. एक base HTML फाइल आपके पास आ गई, फिर ये पहली embedded object आएगी, उसके बाद दूसरी के साथ ऐसे करेंगे तीसरी. So why do I do that? Why don't I send all the 10 requests simultaneously? वो 10 की 10 HTTP request एक ही TCP segment में डाल के भेज देते हैं. ऐसा कर देते हैं. This is called pipelining. तो ये client जो है, ये request है जो server की तरफ भेज रहा है. So client is not waiting for the server to respond to the first request. It's sending all the requests that it has in a pipeline fashion. So in a pipeline fashion, ये यहाँ पे request भेजेगा. It will batch the requests and responses to reduce the number of packets also. Okay. Not just that, इसने जितनी HTTP requests यहाँ भेजनी थी, सर्वर को वो सब की सब मिल गई. सर्वर जो है वो सबका डेटा एक-एक करके भेज देगा. And you can see that यहाँ पे सिर्फ एक राउंड ट्रिप टाइम आपका वेस्ट होगा. Ideally, maybe a little bit more. So you saved a lot here. Pipelining saves a lot here. So now let's take a look at how these HTTP request messages and responses, requests and responses, they look like. There are two types of HTTP messages. One is a request and the other is a response. Request different types की हो सकती हैं, and we will talk about that. So HTTP request message, it's ASCII, human readable format. You captured the packets, पहली programming assignment के अंदर, you captured those packets, and in those captured packets, you could actually see the HTTP request. उसके बीच में आप देख सकते हैं HTTP request. In fact, you will see कि IP addresses भी वहाँ पे लिखे हैं. जो आपकी मशीन का IP address होगा वो वहाँ पे लिखा हुआ उसके बीच में. हेक्स में एनकोडेड होगा, वायरशार्क के अंदर हेक्स में एनकोडेड होगा, बट इट वुड बी देयर। योर ईथरनेट एड्रेस और हार्डवेयर एड्रेस और फिजिकल एड्रेस एक इक्विवेलेंट चीज है, दैट विल आल्सो बी देयर, क्योंकि आप तो वायर पे से पैकेट पकड़ रहे थे। यू आर गेटिंग द फ्रेम्स एंड विद इन द फ्रेम्स देयर विल बी अ फ्रेम हेडर, डेटा लिंक लेयर का हेडर होगा, और उसके बीच में आपके पास आईपी डेटाग्राम होगा, पेलोड के तौर पे आईपी डेटाग्राम, एंड विद इन द आईपी डेटाग्राम यू विल हैव अनदर हेडर, आईपी का हेडर होगा, और उसके बीच में एक और पेलोड होगा, वो पेलोड टीसीपी सेगमेंट होगा, और टीसीपी सेगमेंट के बीच में टीसीपी हेडर होगा, टीसीपी हेडर होगा, and then the application layer data, which would be the HTTP request. और HTTP request itself उसकी किस तरह breakdown हुआ है वो इस slide के ऊपर। So you will see there is encapsulation here. There is encapsulation here. Lowest layer के ऊपर most packaging है, ठीक है। जैसे जैसे वो लेटर नीचे आता जा रहा है, सेक्रेटरी ने एक एनवेलप लगा दिया, फेडेक्स वालों ने दूसरा एनवेलप लगा दिया, उसके और नीचे नेटवर्क में गया तो उन्होंने बड़े बॉक्स में डाल दिया। So as you are moving down the layers, the packaging is increasing. As you move up the layer, जब CEO के पास पहुंचेगा लेटर तो सब कुछ एनवेलप, सब कुछ निकल गया, सिर्फ एक लेटर आ गया। So HTTP request message. So first thing here is the request line, which has one of these methods. Get methods, post method, or head method. There are a couple of other methods as well. किस तरह के होंगे? get/index.html http 1.1 http की वर्जन आएगी। यहाँ पे क्या चीज आप गेट करना चाहते हैं, सर्वर के साथ आप ऑलरेडी कनेक्टेड हैं, your TCP connection is with a server, and from that server provide the complete path to get a file, और ये फाइल आपके पास आ जाएगी। लेकिन अभी ऐसा नहीं है, कुछ और चीजें भी भेजनी पड़ेगी, ये रिक्वेस्ट अभी कंप्लीट नहीं हुई है। दिस इज ओनली द फर्स्ट लाइन, जिसको हेडर लाइन कहते हैं, फर्स्ट लाइन ऑफ द रिक्वेस्ट, एंड देन वी आल्सो हैव दीज other header lines which includes additional information क्या हो सकती है कि वो होस्ट आएगा, उसके अंदर होस्ट आएगा, तो किस होस्ट के बाद, although it is already connected to that source, but sometimes you can configure virtual hosts as well. तो यहाँ पे ये host थोड़ा different भी हो सकता है। So for example, you can connect to www.google.com और यहाँ host की जगह जो है वो आप YouTube लिख के भेजें, that's possible. And then you have this user agent. User agent is for your browser. आपके browser का जो भी agent है उसको specify करते हैं। The server can use this information, user agent information. Server can use this information to send you a crafted response according to your user agent. So if your user agent is telling the server, that you are using a browser on a desktop or a laptop, it may send you a response, a page which is suitable for display on a desktop screen. अगर user agent उसको ये बता रहा है कि this is a mobile browser, is running on a smartphone, okay? So the server may craft the response. Oh, this user agent is from a browser which is running on a small screen device. Small screen device से आ रहा है जिसकी screen real estate बहुत थोड़ी है. So I should send a different response. You can see these days it's pretty common. You try visiting many pages. अगर अच्छी वेबसाइट बनी होगी डेस्कटॉप पे वो कुछ और नजर आती है, और अगर आपको उसको मोबाइल ब्राउजर पे देखें, स्मार्टफोन पे देखें, तो ऐसा नहीं होता कि वही वाली वेबसाइट वहां पे नजर आती है। If the website is like this, वो इसको यूजर एजेंट को देख के आपको भेज, and then it will provide कि क्या क्या चीजें एक्सेप्ट कर सकता है, एनकोडिंग किस टाइप की होगी, and then this is important, connection keep alive या क्लोज कर देंगे या कीप अलाइव। क्लोज कब कर देंगे? जब नॉन परसिस्टेंट करना हो। कीप अलाइव कब करेंगे? जब परसिस्टेंट करना हो। Now it is possible that the client sends a request or the server sends a response. The client and server, they might be running different versions of HTTP. कोई एक HTTP 1.0 यूज कर रहा हो तो वो persistent TCP connections को सपोर्ट ही नहीं करेगा, नहीं सपोर्ट करेगा, so that means connection close होगा ही होगा। Okay. And then after that, carriage return and line feed. ये HTTP का पार्ट है, carriage return line field. So this is how the message will look like. ये exactly वही message है, exactly वही message है. Oops. Exactly यही message है और इसको जो है ना ये इस शक्ल में. This would be exactly that. This is exactly like that. ऐसे character after character इसी तरह से. If you capture the packets Wireshark पे करें तो आपको exactly ऐसे नजर आए. Exactly ऐसे नजर आए. You have the method, some space, URL, origin, etc. So this is the request line, and then you have the header lines, and then you may have this optional body. Optional body. Optional इसलिए कह रहे हैं कि यहाँ पे कुछ जाएगा. Normally it is empty, but sometimes the client want to send some data to the server. हमने एक example दी कि dictionary की example है. So you are going to a dictionary website and you want to look up the meaning of a word. वो वर्ड आप कहाँ भेजेंगे? वो वर्ड इस जगह पे भेजेंगे. Okay. So other HTTP request method, post method में web page often includes form input. So user input sent from client to the server in entity body of the HTTP. वो यहाँ पे ये entity body के अंदर post message चलता है. So instead of get method, यहाँ पे आपका जो method है यहाँ get की जगह पे post लिखा हुआ. Simple. And get method is for sending data to the server. Includes user data in the URL feed of HTTP GET request message. ये इस तरह से आपके question mark के बाद जो है वो लिखा होगा this will be uploaded to the server. अच्छा, there is a couple of other methods. Head method है. Head method क्या होगा कि it is equivalent to the get method, except that the server will respond. बाकी सारी चीजें रिस्पॉन्स उसका नॉर्मल आएगा, लेकिन जो उसने फाइल भेजनी थी वो फाइल नहीं भेजेगा. हेडर सिर्फ भेज देगा आपके पास और कुछ नहीं भेजेगा. किस लिए इस्तेमाल होता है? चेक करने के लिए कि सर्वर चल रहा है या नहीं चल रहा. यू डोंट वांट टू वेस्ट द बैंडविड्थ. एक किस लिए इस्तेमाल होता है? एक और भी इसका यूज है. वो यूज ये है कि लेट्स से यू हैव डाउनलोडेड अ फाइल and now you are not sure whether the file has changed on the server or not. तो आप head method भेजेंगे, वहां सर्वर आपको रिस्पॉन्ड करेगा और बता देगा, उसके अंदर बता देगा ये फाइल जो है ये लास्ट इस टाइम पे चेंज हुई थी. इफ इट्स द सेम टाइम that you have on the file, तो फिर आपको दोबारा करने की जरूरत है. If it is changed, then you will request that file by using the get method. Put method जो है वो फाइल पूरी अपलोड करने के लिए इस्तेमाल होता है. So HTTP response message में क्या होगा? बिल्कुल उसी तरह से एक स्टेटस लाइन होगी. वहां पे रिक्वेस्ट लाइन थी, रिक्वेस्ट लाइन के बजाय यहाँ पे स्टेटस लाइन होगी, which would be HTTP 1. प्रोटोकॉल का नाम होगा, and then 200 OK, these are the codes. ये 200 OK equivalent है, part of the protocol. And then you have these header lines, just like you had the header lines in the request. Response के अंदर भी ये header lines होंगी. वो date उसने लिखी होगी, फिर सर्वर अपना बताएगा. जिस तरह यहाँ यूजर एजेंट था उस तरह उसने सर्वर ने बताया. तो what I am last modified file कितनी. So head method के अंदर भी ये last modified आपके पास आएगा. And if this last modified is the same as the file you have, so that means you have the latest file. You don't need to send the request for this file again. And then additional header lines. और भी इसके अलावा बहुत सारी होती हैं. स्टैंडर्ड के अंदर लिखी हुई है कि क्या मतलब होता है इसका. Content length tells you कि whatever will follow this, उसके content का size कितना है. And the content will be right after. ये पूरा डेटा आएगा इसके बाद. पूरी HTML file or image file or whatever file that you have requested. So HTTP response के status codes क्या होते हैं? So normal request, you send a request, आपके पास file आ गई, 200 OK होता है. Everyone has seen this 404 not found. You sent a request for a file which is not on the server. So 404 bad request, server did not understand. आपने कोई malformed request भेज दी. So for example, instead of a browser, you are writing a piece of code and you are trying to implement the HTTP protocol yourself. आपने यहाँ से request बना के भेजी, but it was not according to the standard, कोई बग था आपके कोड में, तो वो रिक्वेस्ट ऐसी चली गई जो सर्वर अंडरस्टैंड नहीं कर पाया, so 400 उसका रिस्पॉन्स आ जाएगा, 301 मूव परमानेंटली कहीं और चला गया, तो सर्वर एज अ कर्टेसी विल टेल यू कि ये कहीं और चला गया और आपको शायद यूआरएल भी बता दे. 505 not supported, and I think there is a bunch of others सारे स्टैंडर्ड में लिखे हैं, can take a look at that. Oh, you can, by the way, you can try out this HTTP for yourself. ये Telnet या Netcat use कर सकते हैं. These are the programs which are commonly available. You can connect. These are the programs that you can use to connect to your web browser, your web server. आप अपने command line पे use कर सकते हैं. Command line पे use करके you can connect to a web server. जिस तरह इसमें ये example दी हुई है. This will open a TCP connection. After the TCP connection is open, you can send the GET request. You can send the GET request and you will get the response. And you will get the response. Okay? So you'll type this GET request, कोई command prompt के ऊपर, and then you will get the response. Okay? या ऐसे देख लें, या Wireshark चलाएं और ब्राउजर के अंदर जो है URL डाल दें, capture the packets and you will see all of this. So ये HTTP का request response आपको सारी नजर आएगी, पैकेट्स के अंदर नजर आएगी. Okay. Now we had said that HTTP is stateless. HTTP is stateless. एक request भेजी, उसका response आ गया, and the server forgets about it. Server forgets about it. But we do know that web doesn't work this way. Shopping cart आपने डाली है, बीच में कुछ चीजें ऐड कर ली हैं, the server maintains that. तो वो state maintain करता है. Okay? But maintenance of state is not part of HTTP. Is not part of HTTP. HTTP itself is stateless. वहाँ पे हम ये कोई जो there is a method that we use using which the HTTP will be able to recognize a repeat client. Okay? An example of that is इसको skip करेंगे. So websites and client browsers, they use cookies to maintain some state between their browsers. और ये cookie जो है वो part of protocol नहीं है, but you can include this. You can include these cookies within the headers. You can include these cookies within the headers. There are 4 components of a cookie architecture. One is the cookie header line of the HTTP response method. Cookie header line hogi, and then the cookie header line in the next HTTP request message, the cookie file which is kept on the user host managed by the user, and backend database at the website. So with ये example ऐसे इसके बजाय interaction देख लेते हैं. That would explain it very clear. So for example, you have a client, उसके पास ये cookie file होगी. उस cookie file के अंदर जो है ना cookies पड़ी होंगी. And what is a cookie? For every site you have an equivalent number. कोई एक number होगा या some text होगी. एक key होगी जो आपके पास 88734 which will indicate कि eBay will recognize you with this number. eBay will recognize you with this number. ये कैसे set हुई है ये भी पता चलता है कैसे set. So when the client will begin, it will have an empty cookie file, and you can actually clear all the cookies. You can clear all the cookies. अपने browser में जाके सारी cookies clear कर सकते हैं. So this client will send a request to the server. The first request that it sends to the server will be the normal HTTP request. कोई cookie उसमें included नहीं होगी, कोई cookie included नहीं होगी. So this would be the normal HTTP request. It sent the normal HTTP request to the Amazon server. Now, Amazon server on receiving this request, अगर cookie architecture ना use हो रहा होता, तो Amazon ने respond कर देना था. You receive an HTTP request, you will just respond by an HTTP response. Okay. An additional thing in the cookie architecture, what Amazon server does is, because Amazon server वो चाहता है कि इस client को याद रखे, so it will create an ID for this user. It will create an ID for this user, and this ID will be, let's say 1678. Okay? और उसने अपनी backend database में भी डाल दिया. क्लाइंट को नहीं पता चला, क्लाइंट को नहीं पता चला. Now it will send the response back to the client, and within the normal HTTP response, it will include an additional header. एक header line उसने डाल दी है, और वो header line है set cookie 167. When you set the cookie, तो ये cookie file जो थी उसके अंदर जाके उसने लिख दिया कि Amazon 1678. What that means is कि Amazon recognizes this user by this cookie 1678. ठीक है? अब Amazon को पता है कि 1678 पे ये वाला काम. Now, once this happens, this guy, when sends the next HTTP request, it can include the cookie 1678 here, and then the Amazon guy, Amazon server will recognize this guy. Okay, oh, ये तो वही है, okay, and then it will have access to the backend database. जहां से उसे पता चल जाएगा कि ये वो वाला कस्टमर है, एंड कस्टमर स्पेसिफिक रिस्पांस को इसको भेज सकता है. एंड दिस कुकी फाइल रिमेन्स देयर. कुकी फाइल इज, ये आपके सिस्टम पे फाइल पड़ी हुई है, ठीक है. दिस स्टेज देयर अनलेस यू क्लियर इट. 1 week later you send a request, you send another request, and you will still include this cookie, and the response that comes back to you will again be tailored according to you. Cookies से उसको ये पता चल जाता है ये कौन सा यूजर है. Now by using the cookies,
सर्वर साइड जो की नंबर क्रिएट करी है वो एंड यूजर पे जो है मैसेज देके करी है, क्योंकि फर्स्ट करा कि मैंने cookies डिलीट कर दी है, तो मैंने दोबारा उसे रिक्वेस्ट भेजी है, वो मुझे सेम नंबर नहीं देगा, कुछ और दे देगा. मैक एड्रेस के साथ नहीं करती,
मैक एड्रेस के साथ नहीं करती है, आईपी एड्रेस के साथ भी नहीं करती है. कुछ एल्गोरिथम वो यूज कर रहा होगा so that it will have a unique cookie to identify a user. तो वो मे बी रैंडमली जनरेटेड कुकी जनरेशन के कोई मैकेनिज्म यूज कर सकते हैं उसके अंदर.
तो मैक एड्रेस के साथ ऐसा करने रहता तो फिर स्टैटिक ना जैसे कि एक यूजर को टर्मिनेट एसोसिएट है किया.
हां,
तो वो इज convenient.
So here is a problem with that कि the MAC address, your MAC address is not known to the server. आपका MAC एड्रेस सर्वर को नहीं पता होता. रिक्वेस्ट में आईपी एड्रेस जाएगा, MAC एड्रेस नहीं जाएगा, because IP address is the one which is used for global delivery. MAC address is only used for local delivery. So I send a packet from here. This guy is connected to the Wi-Fi access point somewhere here. Okay. I will send a frame. In fact, I will send an application layer data encapsulated in a TCP segment, encapsulated in an IP datagram, encapsulated in a MAC layer frame. Okay. MAC layer frame में भेज दूंगा, and I will send this MAC layer frame to the next hop, and the next hop is the guy that I'm directly connected to. It's on the same network. That guy knows my MAC address. That guy knows my MAC address. Okay. As long as it is on the local network, everyone will know my MAC address. जिसको भी मेरा पैकेट मिलेगा, they will know my MAC address. But a router which is in SSE building, कहीं basement में लगा हुआ है, ठीक है? The router which is in the SSE building, उसके पास जब ये वो मेरे नेटवर्क पे, उसका एक इंटरफेस मेरे नेटवर्क पे, उसको भी मेरा मैक एड्रेस पता चल जाएगा, उस राउटर को भी मेरा मैक एड्रेस पता चल जाएगा. Now this router will extract the IP datagram, because the router has to work on the IP datagram. It doesn't work on the MACs. It doesn't work on the link layer frames. The router works on the IP datagrams. It does not work on the data link layer frames, because there is a data link layer between myself and that router, and that data link layer is finished. Remember, हमने last time नहीं बल्कि एक दो लेक्चर्स पहले हमने कहा था कि for a global delivery you have many different link layers concatenated with each other. ये एक लिंक लेयर है जो वायरलेस के ऊपर वाईफाई के प्रोटोकॉल को यूज करके वायरलेस एक्सेस पॉइंट पे जा रही है. उसके आगे एक और मैक लेयर है जो लाइब्रेरी बिल्डिंग के अंदर जा रही है. एक और मैक लेयर है जो एक ऑप्टिकल फाइबर पे लंप से बाहर जा रही है. सो these are all different MAC layers, data link layers, all different data link layers. अपने अपने प्रोटोकॉल इस्तेमाल करते हैं, ठीक है. So my MAC address does not go outside my local network, does not go outside my data link layer. उस राउटर ने एक दूसरे राउटर के साथ कनेक्टेड है, उसने आईपी डेटाग्राम आगे भेजना है, तो जब वो आईपी डेटाग्राम आगे भेजेगा, वो भी ऐसे नहीं है कि आईपी डेटाग्राम सीधा से सीधा भेज दिया, उसने उसको भी फ्रेम में बंद करना, डेटा लिंक के फ्रेम में बंद करना है। डेटा लिंक लेयर के फ्रेम में बंद करेगा तो वहां पे एक वो मैक एड्रेस डालेगा, लेकिन वो मेरा मैक एड्रेस नहीं होगा, मेरा मैक एड्रेस नहीं होगा, आईपी एड्रेस मेरा ही होगा, but the MAC address would be the interface, would be the address of the interface of the router, जो उसका outgoing interface होगा उसका MAC address होगा। Make sense? जी।
इस सर्वर को ये बाउंड कर सकते हैं या कोई ऐसी पॉलिसी है कि अगर सर्वर हमें कुकीज हमारी क्लाइंट साइड पे जो करना चाहता है, सेट करना चाहता है और हम उसे नहीं एक्सेप्ट करते, तो क्या कोई ऐसी पॉलिसी है? तो समटाइम कुछ वेबसाइट्स ऐसी होती हैं जो हर हाल में आपको कहती हैं कि आप कुकीज एक्सेप्ट करें या
Cookies accept.
तो इज देयर एनी पॉलिसी जो सर्वर को बाउंड करती है?
That's a very big question. आजकल जो प्राइवेसी के इश्यूज हैं सारे डिपेंडेंट कुकी ट्रैकिंग होती हैं और थर्ड पार्टी कुकी ट्रैकिंग है। So it is possible that some websites will not allow you to use their content or browse their content if you don't accept it, but other sites might still allow you to use that. उनके ऊपर डिपेंड करता है। कंटेंट
पॉलिसी कोई
स्टैंडर्ड पॉलिसी कोई नहीं है, स्टैंडर्ड पॉलिसी हो तो प्राइवेसी के तो इश्यू रिजॉल्व हो जाते हैं, कोई स्टैंडर्ड पॉलिसी नहीं। और इसकी पॉलिसी कौन बनाए?
सर जीडीपीआर की एक है कि आपको साइट्स को अप्लाई करनी पड़ती है, पॉपअप दिखाते हैं यू नीड टू एक्सेप्ट इट। जीडीपीआर के अंदर ये है कि आपका जो डेटा है, if it is residing there, the data does not go outside the European Union के लिए है जीडीपीआर, उसकी प्रेमिसेस से बाहर नहीं जाना चाहिए। बाकी जो जीडीपीआर भी और कुछ नहीं, अगर कुकी मैंने नहीं एक्सेप्ट की और कंटेंट साइट कहती है कि नहीं हम आपको नहीं दिखाते, तो दे आर फ्री टू डू दैट, इज देयर प्रॉपर्टी, जीडीपीआर भी उसको बाउंड नहीं करता। यस, कुकीज आर देयर, इसको एप्लीकेशन लेयर सेशन आईडी कह सकते हैं, बट सेशन आईडी जो है ना, इट्स अ वेरी जेनेरिक टर्म, बहुत सारी चीजों के लिए इस्तेमाल होता है सेशन आईडी। आई वुड नॉट वांट टू कॉल इट सेशन आईडी, बट रियली अगर एक सेशन आप इसको समझते हैं तो उसका आईडी मतलब, लेकिन इसका पर्पस सिर्फ यही है कि वो उस क्लाइंट को रिकॉग्नाइज करे जो जिसके साथ पहले इंटरेक्शन हो चुका है। हाँ जी, मुझे पता नहीं है सेशन आईडी आप किस चीज को कह रहे हैं, कोई आईडी नहीं होता उसका, कोई आईडी नहीं। So cookies, although it's nice that you want, there are many things that you would like to use cookies for. Recommendation systems के लिए, you know, some website, Amazon should know my interest. Amazon should know my interest so that it can show me discounts on things that I like. Okay. Recommendation systems यही करते हैं कि वो देखते हैं, आपको वो बता देंगे कि since you purchase this, you might like this, or since you browsed this, you might like this, or since you purchase this thing goes well with this, and इस तरह के 50 क्वेश्चंस हैं, वो उन्होंने उसके ऊपर अपना रिकमेंडेशन सिस्टम बिल्ड किया, मे भी 50 से भी ज्यादा। I used to have a list of those. So what cookies can be used for? For authorization. For authorization, उसका यूज हो सकता है। शॉपिंग कार्ट, अगेन रिपीट कस्टमर, जो रिपीट कस्टमर आया डेटाबेस में मैंने डाला हुआ है, इसने अपनी शॉपिंग कार्ट के अंदर ये 6 चीजें डाली हुई थी। Now this guy is sending me a request, maybe a 7th item is being added to the shopping cart. I already know that there are 6 items for this guy which are in the backend database. सर्वर को ये पता है, सर्वर जाके वो 7th item भी ऐड कर देगा उसके अंदर। The shopping cart is still maintained at the server, वहां पे सिर्फ उसने ये किया कि उस क्लाइंट के वो उस कुकी के थ्रू रिकॉग्नाइज कर दिया। Recommendations, So the server can provide recommendations to you if they recognize who you are and what is your history. User session state वेब ईमेल के अंदर जिसमें आपके पास आपको बार-बार जो है वो लॉगिन नहीं करना. So how to keep the state at the protocol endpoints? Maintain the state at sender receiver or multiple transactions. In messages, cookies जो हैं वो HTTP messages के अंदर पे जाते हैं. Now, as I said, कि cookies और privacy जो है ना, this is something which is extremely important these days. So lots of talk about privacy. Cookies permit site to learn a lot about you on their site. Sometimes you like this, sometimes you like this. You would like that to get the discounts on things that you like. But sometimes you may not like this because the third-party persistent cookies or tracking cookies, there is a whole subject of tracking cookies. वो आपके interest को track करती हैं and you might be getting some spam or advertisements that you may not like. आप advertisements ऐसे देखते हैं. Your interests are being disclosed to third party. Amazon तक तो ठीक था, लेकिन Amazon जो है वो आपके interest किसी और को disclose कर रहा है. वो कैसे कर सकते हैं? If you go to Amazon's website, they might have an iframe, which is a page within a page. It is a page within a page. उस iframe के अंदर वहां से एक और cookie आपके पास set हो जाए, third party cookie set हो जाए आपके पास. And when you visit another website जिसके ऊपर वो third party का cookie चल रही है, third party का applet चल रहा है, third party का iframe चल रहा है, now they know that you have visited this site and this site and this site. So आपकी पूरी browsing history जो है वो track हो सकती है. And many people will not like that. So it's a very, very interesting third-party cookie. There is a very nice paper on that. अगर किसी को interest हो इसमें, तो बाद में मुझे email भेज के पूछ सकते हैं. So cookies bring state to HTTP. HTTP inherently is not stateful. It's inherently stateless, but cookies bring state to that. हमने HTTP में देखा था, if you bring persistence, you get some efficiency. You bring pipelining, you get more efficiency. There are additional things that you can do. HTTP 1.0 से 1.1 पे गए थे तो आपने persistence and pipelining introduce करवा दी थी. And people went from 1.1 in 1997 to HTTP 2, HTTP 2.0 few years ago, 5-6 साल पहले. So HTTP 2.0 जो है, some additional enhancements. Now people have HTTP 3 as well, which is not standardized yet. हमने आपको बताया था कि standardization का process है, which takes a few years. So some work has started. IETF के अंदर चल रहा है process. Now I'm going to talk about web caches. Web caches also bring efficiency to HTTP and other protocols as well, but we'll only talk about how HTTP benefits from web caches. जैसे ये नाम बता रहा है आपको, we are probably familiar with caching in computer systems. Caching किस लिए इस्तेमाल होती है? Caching इसलिए इस्तेमाल होती है कि if there is a content that you are using, or there is a memory area that you are using, to keep that into your L1 cache or L2 cache or L3 cache, जो आपके प्रोसेसर के ऊपर उसके अंदर रख लें, so that you have a very quick access to that memory area, rather than getting it from external memory. You have caches, which is also a memory. Cache is also a memory, which is on the processor. So time save होता है उसके अंदर. यहाँ पे भी ऐसे हो रहा है. In the case of HTTP, if the server is too far off, it will take you a little bit of time to get the response from the server. तो एक दफा ले दिया, दोबारा उस फाइल की जरूरत पड़ी. Maybe not you, but somebody in your vicinity needs the same file. Okay? Do they have to go all the way to the server? Or can they get the response from somewhere in the middle. Somewhere in the middle कैसे आ सकता है? So there are two topics that are very important and interrelated. One is called caching and the other is replication. When we talk about replication, कोई server के पास एक piece of code था, there is a web application that they are running, जिसके अंदर वो dynamically HTML pages generate करते हैं, as in the case of Amazon and many other websites or eBay, etc. So what they do is that they have this piece of code running on the server using which dynamic pages are being generated. जब request आती है, shopping cart आपने कोई चीज ऐड की, तो dynamic page generate होता है. ये वो pages नहीं है जो कहीं statically उनके file system में कहीं पे पड़े. ऐसा नहीं है. Because you are doing something dynamically. या Gmail के pages पे चले जाते हैं. These are all dynamically generated. Emails are coming in. Pages are dynamically being generated. These are not files, not static files which are placed in their system. उनके file system के अंदर कहीं नहीं. So web caches क्या करेंगे? Web caches ये करेंगे कि if you get a repeat request, you can serve it right away rather than getting it from the server. An example of that would be multiple people on LUMS campus. They are requesting the same content from a server in Europe. ठीक है? पहले मैंने request किया तो ठीक है, यूरोप से आ गया. While the content was coming here, maybe I have installed a cache, just like in a computer system. जैसे चिप के ऊपर L1, L2, L3 कैश लगा देते हैं. मैंने शायद LUMS के IST डिपार्टमेंट में एक कैश लगा दिया, which is a server which will cache that content. If somebody else from LUMS requests the same content, तो उसको LUMS के अंदर से जवाब मिल जाएगा, उसको बाहर जाने की जरूरत नहीं पड़ेगी. Very quick. So you can install a web cache, or sometimes people use the word proxy server for this as well. There used to be slight difference between proxy servers and web caches, but these days there is no difference between. Every proxy will do caching. Okay. So let's say this client sends a request to the origin server. So the request will go through this web cache, and the web cache will relay that request to the server. The server will respond, and the web cache will relay back that HTTP response to the client. So maybe there was this file which was sent back to the web cache, and web cache sent back this file to the client. What web cache did in the meanwhile is that it also kept a copy or cached a copy of this file. और उसकी रीजन क्या है? रीजन ये है कि अगर फ्यूचर में कोई रिक्वेस्ट करेगा, उसको सर्वर पे जाने की जरूरत नहीं है. So let's say this client also wants to get the same file from the server. This will also try to connect to the server, but through that cache. तो उस कैश पे रिक्वेस्ट भेजी, कैश ने वहीं से जवाब दे दिया. And you can imagine that this web cache is probably placed close to both of these clients. जो हमने एग्जांपल दी थी कि multiple people at LUMS, and this server can be very far off, and this web cache is placed closer to the clients. Now, placement of this web cache can be anywhere between the client and the server. कहीं पे भी हो सकती है, किसी भी जगह.
एक्सेस को रिस्ट्रिक्ट भी कर सकते हैं.
रिस्ट्रिक्ट किस सेंस में?
फॉर एग्जांपल अगर मल्टीपल वेबसाइट्स को ब्लॉक करना चाहते हैं तो हम वेब कैश के थ्रू भी कर सकते हैं. जैसे हम
वेब कैश का पर्पस ये नहीं है कि वो ब्लॉकिंग करे. ब्लॉकिंग के लिए जो है वो और टेक्निक्स इस्तेमाल होती हैं और चीजें इस्तेमाल होती हैं. So your service provider can block, but web caches, the purpose of the web caches or proxy servers is not to block. You can do blocking in other ways. So web caches, they basically act as both the client and the server for the original requesting client. जिन्होंने cache अपने पास ये proxy server का address set किया हुआ है, this would be our proxy and would be acting as a client to the origin server. the server tells the cache about objects allowable caching. So वहाँ पे वो cache controlling बता देती है कि max age इसकी. Why there is a need to have a max age or no cache? No cache means के the content is changing dynamically. The content is changing very very rapidly, dynamically. उसको आप कभी cache नहीं करेंगे. Gmail के pages कभी cache नहीं करेंगे. Gmail के pages कभी cache नहीं करेंगे. Articles written down उनको cache कर लेंगे. News sites, maybe you will cache those for a little bit. That is why you have a max age. So for example, if CNN.com updates their website every few hours, तो वो जो भी फाइल भेजेंगे उस फाइल के साथ कह देंगे कि you can cache this for like 15 minutes or 20 minutes or 30 minutes depending upon के whatever they foresee the lifetime of that content. उसके बाद वो change हो जाएगा. Okay, so why do we need web caching? It reduces the response time for the client request. वो आपके पास फौरन से response आ जाएगा. Not for the first guy, but for every subsequent guy. The cache is closer to the client. It would reduce the traffic on an institution's access link. This is very important. अगर LUMS ने यहाँ पे cache लगा दिए, so all the requests that are going for the same content, that content is being served locally. So उससे फायदा क्या हो रहा है? फायदा ये हो रहा है कि LUMS has gotten the service from an external service provider. There is an external pipe, external bandwidth that LUMS is paying for. वो bandwidth आप बचा देंगे. And more often than not, the link between an enterprise or an institution and a service provider is typically the bottleneck link. Just to give you an example, within the LUMS network, we have 1 gigabit per second. एक दो links यहाँ पे कुछ links 10 gigabit per second बनेंगे, but largely rest of the campus is operating at 1 gigabit per second. The connection outside LUMS, वो भी खैर हमारे पास 1 gigabit per second से अब ज़्यादा है, but it could be 10 megabit per second, could be 10 megabit per second, could have been 10 megabit per second. Okay? And typically it is the case that within the organization, within an enterprise, you have very, very high speed links. And the organization is connected to the service provider with a relatively lower bandwidth link because it's very costly. Internally तो हम जो मर्जी कर लेना, मैंने तो एक पाइप ही डालना है, लिंक डालना है, लेकिन बाहर से अगर मैं सर्विस लूंगा तो it would be very expensive. Consider a home network. Home network में आपने वाईफाई राउटर लगाया है जिससे 8 लोग connected हैं. They are all talking to each other at 1 gigabit per second. But you are getting connection from Nayatel or PTCL or Supernet or Cybernet, किसी से भी ले रहे हैं. 20 megabit per second लेंगे या 50 megabit per second लेंगे, 100 megabit per second लेंगे, इससे ज़्यादा तो नहीं लेंगे, because it becomes very, very costly. So you will save on that bandwidth. अगर आप internally caching करें. I think we are a little bit over time. ये topic इसको next lecture के अंदर wrap up करेंगे, खत्म करेंगे, and then we'll talk about a couple of other application layer protocols. ये slides जो हैं ये uploaded हैं LMS पे.